So good morning to all. So this is Eluk Kumar from SNS College of Technology and Department of Computer Science Engineering. So now I'm going to tell about what is thread and multi-threading models with different concept. Threading issue. So semantic and fork and exec system calls will the threading issues will be created. So signal handling will going to avoid threading issues with the synchronous and asynchronous. So thread cancellation of target thread will asynchronous are deferred, and the thread local storage and the scheduler activation. So these are the different thread issues occur in a thread. And the semantic of fork and exec. So does fork duplicate only the calling thread or all threads? It means some Unix have two variants of fork system call. So execute system call usually work as a normal, so replace the running process including all the threads. Signal handling. So n signals are used in a Unix system to notify a process that a particular event has occurred. A single handler is used to process signals. In a single is generated by a particular event, and signal is delivered to a process, and the signal is handled by one by two signals handlers, and default, and it is user defined. So n every signal has default handled that the kernel runs when handling signal. One is a user defined signal handler can override default, and then for a single thread and a single delivery process. Signal handling. So n where should a signal be delivered for multi-threaded. So one is deliver the signal to the thread to which the signal applies, deliver the signal to every thread in the process, deliver the signal to certain thread in the process, assign a specific thread to receive all signals for the process. Thread cancellation. So thread cancellation means terminating the thread before it is finished. So it means if we have a two process occur, and so one process using the one resource, and another process using the same resource, means it should be wait and accomplish the resource. Otherwise it will force to complete the resource. For that the execution program is stopped and then given the resource to another process. So this type of process will can terminating it before it get finished. So thread can be cancelled. It is target thread. So whenever we process it is a target thread, we can be cancelled during the execution of time. So two general approaches are in the thread cancellation. So one is asynchronous cancellation and is deferred cancellation. So asynchronous cancellation means it terminates the target thread immediately, and deferred cancellation allows the target thread to be periodically check if it should be cancelled. So pthread coder to create and cancel thread. So we have a pthread.tad and create a thread is a pthread.create of and id, 0 worker, null. So cancel the thread in pthread.cancel of TID. So TID is a transaction ID. So it will useful to identify the different process cancellation. And also the thread cancellation invoking thread cancellation request cancellation, but actual cancellation depends on the thread state. So we have a mode and a state and type. So we have half and a disabled and a deferred enabled and asynchronous enabled and deferred and asynchronous. So this type of cancellation is disabled. The cancellation remains pending until the thread is enabled. So default type is deferred. So cancellation only occurs when the thread is reaches cancellation point. So other than we cannot going to cancel the any point of the threads. Then the cleanup the handle is invoked. The cleanup handle is invoked to clear all the threads cancellation involved. So on a Linux system, the thread cancelling is handled through signals, so not in a comment. Thread local storage. So the thread local storage means it allows to each thread to have its own copy of data, and it is very useful when you do not have any control over the thread and creation process. Example, when using a thread pool. So different from local variables. So local variables are visible only during single functions invocation, and transaction leverage service visible across functions invocations. Similar to static data, the TL is unique to each other thread, and it is a scheduler activation. So both and two-level models secure a communication to maintain the appropriate number of kernel threads and allocate to the applications. So typically use an intermediate data structure between user and the kernel thread. So on the lightweight process of LWP, so appears to be a virtual processor on which process can schedule user thread to run. So each LW attached to kernel thread. So how many LWPs to create? And the scheduler and activation provide upcalls of communications mechanism from the kernel to the upcall handler in the thread library. So these communication allows an applications to maintain the correct number of kernel threads. For example, user thread and the lightweight process and the kernel thread in the right side. So these are the different references for these thread issues and thread sharing things. So these are the different kind of threads, and the thread is used in operating system. Thank you.